So what we're looking at next is going to be the 2022 higher level paper B1, and it's looking at planar surfaces. So it'll give you, in the question when you see it, it gives you coordinates, x, y and z coordinates for a number of different points. So we always start off by drawing an xy line across the page, and just set out that this is our 0 mark here, just so there's plenty of space there. We can work off that. Okay, so looking at each of the points down along, we set out the first number that it gives you on each of the lines is your x coordinate, so it's from 0 in as far as the location of the point. So for A, the x coordinate is 160. It gives us a y and a z coordinate. I'm just going to draw a nice light line first of all. Y coordinate is 40. That's going to be the elevation of A, and the z coordinate is 70. So that is the plan of point A. Okay, so we have point A in elevation and point A in plan. Now, we can go ahead and fill in the other points B, C, D, E, F and G using the coordinates. G is the only one that has some unknowns, so we're going to work with what we have first of all and progress. Okay, so once we have the points plotted, we can see that point C and point E are sitting on the horizontal plane. Okay, so they're actually sitting on the ground. We can go ahead and complete the planes ABC first of all. So in elevation and plan we can join those up. ABC. And plan do the exact same thing. So ABC in plan can be complete as well. ABD can also be completed. So in elevation shows you in the question that it is behind the plane ABC, so we're just going to show the hidden detail with a broken line like so. And the same in plan view, it's behind or underneath. Plane ABC. But their common edge is AB, so that's common to both of them. Alright. We also can join E to F in elevation and E to F in plan. Now, we are unable to locate the point G as of yet because it does not give us that coordinate in the question, but we know it has to be somewhere up along this section here in elevation and here in plan. So we'll take a look at what we do next. In the question, it has a symbol on the line BD in elevation like this, and that shows if there's a pair of lines like that, it shows that they are parallel to each other. So BD and FG are parallel. So we can set up our sliding z squares here at the top, move down to F, strike our line out, and where it hits this vertical from G is going to be point G in elevation. Okay, so we can join that back to point E on the ground line. I'll just straighten that line here as well and put those symbols on so they're parallel to each other. Okay. In plan, it also shows that BD and FG are parallel. So again, we take our sliding set squares, BD, and strike our line from F to create the line FG. So that locates the point G in both elevation and plan. Now we have our two planar surfaces, or three planar surfaces even, complete and ready for the next section. Part B of the question asks us to determine the dihedral angle between the planes ABC and ABD. So what we're looking for first of all is the line of intersection. So LOI, and the line of intersection between both those planes is the line AB. What we're looking to do is to get a true length of that line, and how we do that is we'll view it perpendicularly to that line. So what we'll do is we'll set up our ground line here. We'll project it down. Set up that we can project point C, point A, point B, and point D. Set up an X1, Y1 line. To do that, it just goes parallel to the line AB already. So this is a ground line. Again, it's an elevation we're taking. So the heights of the points don't actually change. So again, just to speed things up maybe for processing or for marking out, we'll take our compass, find point A here. Point C is on the ground. Point B is our height here. Point B. Point D. Now we have the line or the plane A. D. So they are crossing over each other at the moment, but it is now a true length of the line AB is what we have. Next we're looking along the line AB, so we're trying to get a point view of the line AB. So we're going to project up here, try and keep it close enough so that you can see it here on the screen. Bring in point C and point B with us here. Okay. With this, we are looking to go again perpendicular to that. So we'll set up our guideline. Keep it close by, and that's going to be our X2 y2 line. So we're looking for a second auxiliary. That's what we're looking at. Now, the distances we're taking, so for our first auxiliary we go back 2 views. So we go back to plan and then we go back to elevation to take our distances here. Okay. Next time we're looking at going from the second auxiliary, from first auxiliary back to the plan view. So we're actually working from the x1, y1 line back to the plan view. Now, to shorten our distances just for neatness and accuracy, just going to set up a benchmark line. We can actually set it up on the line AB if we want to. So this one here is going to be x1 dash y1 dash. Okay, so just to shorten our measurements that we're taking. Now in this case, AB is now on the line. Okay, so it's set up here. Point C is going to be taken from the line here back to the point. Follow line C up. And point D is set up here. Now we have so finally our dihedral angle is the angle between the two planes here, and if we take a look at the question, it just says to determine the dihedral angle. You could put your protractor on that just for completion's sake. Set up your 0 and we take our measurement of approximately 12 degrees, and that would be part A and B of 2022 question.